Welcome to Vani Sudhir Mathematics online class. Today we are going to introduce sequence and learn various types of sequence. Let me play the animation for you. Okay. Okay. Before that, let us see some patterns. In honeycomb, we can see identical hexagon shaped holes. Honey, no, yummy. In sunflower, we can see identical petals at equidistance. In pineapple, we can find out some other natural patterns. Sequence is a list of numbers listed in a specific order with some specific rule. Let us see some examples. Here we are having a sequence starting with 2 and each term thereafter is 2 more than previous term. For first term, if you add 2, you will get second term 4 and the third term is obtained by adding 2 to second term, that is 4 plus 2, 6 and so on. We'll see another sequence. Here we have to multiply with fixed number. Starting with 2, each term thereafter is 2 times the previous term. Okay. The second term, how it is obtained? By multiplying with 2. Third term, 8, how it is applied? By multiplying second term with 2. 4 times 2 is 8. Fourth term, 16, how it is applied? By multiplying 2 to the third term, 8. 8 times 2 is 16 and so on. The first, we can have another sequence like this, whose first two terms are 1 and each term here see third term 2, how it is obtained by adding first two terms. Fourth term, how it is obtained by adding 2 of its previous term, that is 1 plus 2, 3. 5, how it is obtained by adding its previous two terms, 2 plus 3, 5. And 8, how it is obtained by adding its two previous terms, 3 plus 5, 8, and so on. Now we will discuss about arithmetic sequence. If the successive terms are obtained by adding a fixed number to the preceding term, then such list of numbers is said to form an arithmetic sequence. How many matchsticks are required for making this figure? 3 matchsticks are required. Next, for the same figure, if we add 2 more matchsticks, we'll get another shape like this. Here, how many matchsticks are there? 3 plus 2, 5. If you add 2 more matchsticks, we'll get another shape like this. Here 7 plus, so previous term 5, we are adding 2 here. So we are getting, therefore total 7 matchsticks are there. Again, if you join 2 more matchsticks, 7 plus 2, so 9 matchsticks are there. Here starting with 3 and each term thereafter is 2 more than previous term. So the list of numbers form an arithmetic sequence. The fixed number added is called the common difference. That is, here 2 is the common difference. Let us find the nth rule for the sequence. First term is 3. Second term, we are adding 2 for it. First term, 2 for first term. 5 it is. Third term, we are adding 2 times. For fourth term, for the first term 3, we are adding 2 3 times. Repeated addition is multiplication. So instead of adding the 3 times 2, we can write 3 times 2. Similar, so and so on. Similarly, we can get u and first term for first term 3, we have to add 2 for n minus 1 times c. If we are adding n minus 1 times, we can multiply n minus 1 into 2. Now you can use distributive property. It will be 2n minus 2. Finally, you will get nth rule as 2n plus 1. See, nth rule is also called nth term of the sequence. Let us discuss some more interesting sequence, some more examples. Natural numbers, they are the counting numbers 1, 2, 3, 4 and so on. Whole numbers start with 0. If you keep on adding 1 to previous term, you will get the whole numbers. It is also a sequence. These two are infinite sequences. We can also take finite number of natural numbers, that is sequence with n natural numbers. If we add 1 to each natural number, we get a new sequence whose nth term is n plus 1. If we subtract 1 from each natural number, we get another sequence whose nth term is n minus 1. If we multiply each natural number with 10, we get a sequence whose nth term is 10n. If we divide each term of the above sequence with 5, we get a sequence whose nth term is 2n. Also, this sequence is set of n even numbers. If you subtract 1 from each term, we get a set of odd numbers whose nth term is 2n minus 1. Now, next we will discuss geometric sequence. If the successive terms are obtained by multiplying a fixed number to the preceding term, then such list of numbers is said to form a geometric sequence. Let us consider a square as one whole unit. If you divide into 4 equal parts, then each part will represent 1 by 4. Again, if 1 by 4 part is divided into 4 equal parts, then you will get 1 by 16. Again, if you 1 by 16, again it is divided into 4 equal parts. 1 by 16 you divide with 4, or you multiply with 1 by 4. You will get 1 by 64. Here 1 by 4, 1 by 16, 1 by 64, they form a geometric sequence. If you are multiplying with 1 by 4, we are getting the preceding next term. If you multiply its preceding term with 1 by 4, we will get this sequence. We will find nth rule of another sequence whose starting term is 3 and each term thereafter is 2 times more than the previous term. So first term is 3, in second term it is multiplied with 2, in third term it is multiplied with 2 times. In fourth term, the first term 3 is multiplied with 2 3 times. When you are multiplying, repeated multiplications, we can write in exponential form. That is 2 power 3 we can write. And if you continue like that, you can get un term like that. First term 3 is multiplied with 2 n minus 1 times. That can be written as 2 power n minus 1. So nth rule of the geometric sequence is 3 times 2 power n minus 1. Okay. Next, let us discuss some more examples. I am taking minus 1 first term. Second term, if you multiply minus 1 with minus 1 into minus 1 plus 1 you will get. Again, if you multiply second term with minus 1, you will get the third term. Again, if you multiply third term with minus 1, you will get fourth term. Here, see, when we are multiplying minus 1, even number of times we are getting a positive 1. If it is multiplied for odd number of times, you will get negative minus 1. So here the general rule will be minus 1 whole power n. Another sequence 1024 is there. If it is multiplied with minus half, you will get minus 5 by 12. If it is again second term is multiplied with minus 1 by 2, you will get 256. Third term, if it is multiplied with minus 1 by 2, minus 120, you will get. So first term is 1024, and in general rule or nth term, that first term 1024 is multiplied with minus 1 by 2, 7 minus 1 time, n minus 1 times. That is minus 1 by 2 whole power n minus 1. Another sequence you see 0.5, that is nothing. If you write in decimal fraction 5 by 10 it is, or we can also say 5 is multiplied with 1 by 10. 0.05 means 5 is multiplied with 1 by 10 into 1 by 10, that is 1 by 10. 2 times it is multiplied. In third term 0.05 means here 5 is multiplied with 1 by 10 3 times. So in nth term 5 is multiplied with 1 by 10 n times. 1 by 10 whole power n you can write. One more sequence I have taken root 2 first term. Root 2 is again multiplied with root 2 to get 2. Again, if it is multiplied with root 2, you will get 2 root 2. So, root 2 nth term is root 2 whole power n. For competitive exams, we need shortcuts to find nth term of a sequence. How in linear sequence, each term differs from the previous term by a fixed number. Let the general term of the linear sequence be an plus b. Here a, b are real constants and n is a variable. First we need to construct a table with n and un values respectively. If n is 1, n plus if you take 1, un will be a plus b. In n place if you take 2, un will be 2a plus b. n place if you take 3, un will be 3a plus b, and so on. Let us calculate the first difference, that is denoted by delta 1. That is the difference between two successive terms of a sequence. Un terms, two successive terms of un terms you have, which is a. If you subtract 3a plus b and 2a plus b, again you will get a. Here first difference are all are same. Let us find the general rule of a sequence 16, 11, 6, 1, minus 4 and minus 9 and so on. First we need to construct a table with n and un values. N values are 1, 2, 3, 4, 5. Un values, they have given the sequence. In sequence we are having 16, 11, 6, 1, minus 4. Now we need to find the, we have to find the nth rule, nth term or general rule. We have to calculate the first difference. 11 minus 16 minus 5. 6 minus 11 minus 5. 1 minus 6 minus 5. Minus 4, 1 minus 1 minus 5 it is also. If you compare the two tables, we will be having a value as minus 5 and a plus b value as 60. Substitute in the place of a, you substitute minus 5, you will get minus 5 plus b equal to 16. Minus 5 you transpose to that side, then b will be equal to 16 plus 5. So b equal to 21. Now we can write the general rule. A plus you have to take minus 5, b plus you have to take 10. Then un or nth term will be minus 5n plus 21. You can say 21 minus 5n also. Similarly, nth term of quadratic sequence can be an square plus bn plus c. First we need to construct the table. When n values are 1, 2, 3, 4, 5, un values will be a plus b plus c, 4a plus 2b plus c, 9a plus 3b plus c, and so on. Let us calculate the first difference, delta 1. First difference, first term is 3a plus b, 5a plus b, 7a plus b, 9a plus b. Again, we need to calculate second difference, delta 2. That is the difference between the terms of the first difference. That is 5a plus b and 3a plus b. Its difference is 2a. 7a plus b minus 5a plus b, 2a. 9a plus b minus 7a plus b, you will get 2a. So second difference are same for quadratic sequence. One example will crack the formula for one quadratic sequence. 1, 3, 6, 10, 15. First we need to construct table with the n values and un values respectively. Delta 1 we have to calculate, that is 3 minus 1, 2, 6 minus 3, 3, 10 minus 6, 4, 15 minus 10, 5. Delta 2, second difference you have to calculate, 3 minus 2, 1, 4 minus 3, 1, 5 minus 4, 1. Next, comparing both tables, we have 2a equal to 1. So a equal to 1 upon 2. 3a plus b will be equal to 2. Substitute a value 1 by 2. So 3 by 2 plus b will be equal to 2. 3 by 2 you transpose to that side. Then b will be equal to 2 minus 3 by 2. That is 1 by 2 only. Now first term of un is a plus b plus c. Here in sequence it is 1. So a plus b plus c equal to 1. Substitute a value 1 by 2, b value 1 by 2. So 1 by 2 plus 1 by 2 it is 1. 1 plus c equal to 1. So c equal to 0. Now we can write the general rule. A value we have to take 1 by 2, B value we have to take 1 by 2, C value is 0. Therefore, Un is half times n square plus n. Now let us see some simple quadratic sequence. 1, 4, 9, 16. See, they are square numbers. 1 square is 1, 2 square is 4, 3 square is 9. Squares of n natural numbers we can see. So its nth term will be n square. If you subtract 1 from each square number, we get a new sequence whose nth term is n square minus 1. If we add 3 to each square number, we get a sequence whose nth term is n square plus 3. If you multiply with 3, we'll get a new sequence whose nth term is 3n square. Now, we'll find nth rule for cubic sequence. Let the general term of cubic sequence be a n cube plus b n square plus c n plus d. We have to construct a table with n values 1, 2, 3, 4, 5. Then un values is a plus b plus c plus d. When n is 2, un value is a plus 4b plus 2c plus d. If it is 3, un value is 27a plus 9b plus 3c plus d, and so on. Delta 1 first level difference you have to calculate. Next, second level difference you have to calculate. 12a plus 2b, 18a plus 2b, 24a plus 2b. Here, second level difference are not same. So, we will go for third level difference. For cubic sequence, we will have 3 18a plus 2b minus 12a plus 2b, you will get 6a. 24a plus 2b, if you subtract 18a plus 2b, you will get 6a. Third level difference are same for cubic sequence. Now we will crack a formula. We'll find a nth rule for this sequence 2, 8, 20, 40, 70. It is a cubic sequence. First we need to construct table with n values, un values. Next, first level of difference 8 minus 2, 6, 20 minus 8, 12, 40 minus 20, 20, 70 minus 40, 30. Second level of difference you see 12 minus 6, 6, 20 minus 12, that is 8, 30 minus 20, 10. Third level of difference you have to calculate 8 minus 6, 2, 10 minus 8 to 2. Third level difference are same. Now we have to compare the two tables to get the nth rule. First we have to find A, B, C, D values. 6a will be equal to third level of difference I am comparing first. That is 6a will be equal to 2, then a is 1 upon 3. Now second level of difference, if you compare 12a plus 2b will be equal to 6. A value substitute 1 by 3. 12 times 1 by 3 is 4. 4 plus 2b is 6. 4 you transpose to that side. 6 minus 4 means 2. 2b is 2. Then b will be 1. Now first level of difference you compare. 7a plus 3b plus c will be equal to 6. Substitute a value, b value. A value 1 by 3 if you substitute, first term will be 7 upon 3. B value if you substitute 1, second term will be 3. 7 by 3 plus 3, it is 16 by 3. So 16 by 3 you transpose to that side. Then C value will be equal to 6 minus 16 by 3. If you simplify 8, 18 minus 16, 2. So C value will be 2 upon 3. Now if you compare the UN terms, first will be A plus B plus C plus D. Here in sequence it is 2. So A plus B plus C plus D value is 2. Substitute A value, B value and C values. So 1 by 3 plus 2 by 3, it is 1. 1 plus 1, 2. So 2 plus d will be equal to 2. So d will be equal to 0. Therefore, you have to substitute a value, b value, c value, d values in general term to get the general rule. And here you can take n by 3 common. You will get a quadratic polynomial n square plus 3n plus 2. You can factorize it. Its factors are n plus 1 and n plus 2. So finally, we'll get the formula n rule as n times n plus 1 times n plus 2 times upon 3. Now, let us see some simple cubic sequence. Cube numbers here 1, 8, 27, 64 are cube numbers. Cube numbers of natural numbers. So n rule will be n cube. Subtract 1 from each cube number, we get a new sequence whose nth term is n cube minus 1. If we add same number to each term, we get a new sequence whose nth term is n cube plus 5. If you multiply each cube number with 2, we get a new sequence whose nth term is 2n cube. Please mail us to ssudhirkuma@gmail.com to give your valuable feedback and request for the concepts to be prioritized. Also, like and subscribe for more videos.